So today we will be talking about two very important concepts, or you can say state-of-the-art models. These are all the state-of-the-art models that I'm talking about, attention model, or today we will be talking about BERT and Transformers. So they are state-of-the-art models. Okay. So one, we have already seen attention model. Today we will be talking about two very important and very new, I would say. Well, these are like a very मतलब बहुत recent advancement है ये, ठीक है? So we will be talking about these two advancements, which are known as transformers. Then even after transformers, we had something known as BERT. BERT के बाद भी आपका GPT आया हुआ है picture में, but GPT is not a part of your syllabus, so I will not go into that. But just for you to know that apart from BERT also, we have one more advanced version available now, which is known as GPT. ठीक है? तो आज बात करते हैं ट्रांसफॉर्मर्स के बारे में एंड बात करते हैं यार BERT के बारे में. So let us start with transformers first. Okay, this is the architecture of transformers. Okay, instead of drawing it by myself, I am showing it to you here by taking help of some pictures taken from the internet. Okay, we will try to understand how things are going to work here. Okay, so these both figures are same only. This is the superficial view and this is the view when we get inside transformer. Okay, तो बात करते हैं transformer के बारे में. Again, if you have to get a relationship, the relationship is simple. Let me just draw that relationship first, then we will proceed ahead with transformer. So just a second. So first of all, you have conventional RNN models. Okay, then slight updation in RNN was LSTM and GRU. LSTM, GRU. Then we have bidirectional RNN. So let me just erase this. Right, then you have attention model. Okay, यहाँ तक we have seen the things, we know how things work. यहाँ तक सब कुछ I guess is clear to you. Okay, then after attention model, you have a recent advancement known as transformer. Okay, and after transformer, you have BERT. Okay, and BERT के बाद भी I was saying you have one more advancement which is known as GPT. Okay, GPT-4 has been launched, so GPT-4 let's say. Okay, this is the flow that you can keep in mind. We have seen all these things till now. We have seen what is RNN, we have seen what is LSTM, GRU, bidirectional RNN, attention model देख लो. आज बात करेंगे ट्रांसफॉर्मर्स एंड BERT के बारे में. GPT is not a part of the syllabus. ठीक है. So let us talk about transformers first. अच्छा, before even showing this figure to you, let me show you one more picture. Just give me a second. Right. Okay, so this figure that you can see, okay, this figure that you can see, this is the picture of your, I can say, transformer. Okay, this is conventional transformer that you have. Okay, now here again you can find that on the left side you have the encoder section, on the right side you have the decoder section. ठीक है, तो इस पिक्चर को 2 मिनट के लिए अपन दिमाग में रखो and we will talk about that here. Okay, कहने का मतलब, if you can recall attention model, in case of attention model you had decoders here, okay, and you had encoders here, right? encoder से input जाता है, एक adder gate में लगता है और addition gate में लगता है, and then it is passed to decoder, and decoder में you simply get the output. ठीक है, this is a simplified example or simplified version of your attention model, right? We have seen these things in previous class. तो positioning देखो, decoder कहाँ है, encoder कहाँ है? Decoder is here, encoder is here, right? This is with the case of attention model. But when we talk about transformers, the architecture is going to change. How? You will have encoders here, okay, and you will have decoders here. Quite similar to the way how conventional encoders and decoders were placed when we were talking about encoders and decoders for the first time. तो उस टाइम जैसे encoders and decoder place किया गया था, उसी तरह से transformer में भी they are placed, okay, like left side में encoder, right side में decoder, okay. The same thing you can see here in this particular figure, right? On the left side you have the encoder part. अंदर में क्या लिखा हुआ है, don't worry about that, we will discuss, okay. So encoder में left side you have the encoder. Just try to understand the outline first. So on the left side you have encoder, on the right side you have decoder, okay. ये architecture होगा with respect to your transformer. So simply you can understand it like this, okay. So you are going to give the input here and you are going to get the output here, okay. This is how things are going to work, okay. अब इस फिगर को, ये जो फिगर I have drawn, this is with respect to transformer, okay. So when we try to zoom in or when we try to get deeper into this figure, okay, what do we get? We get this picture, okay. So for the time being I'm not including that figure, just for you to understand this is what you have, ठीक है. कहने का मतलब है, just try to focus here for a minute. कहने का मतलब है this entire part was your encoder, है ना. I just drew encoder, so this entire part is your encoder, right? And this entire part is your decoder. Simple as that, right? This is fine. But what peculiar thing you are going to find in case of transformer is that कि encoder part में ऐसा नहीं है कि you will have only one encoder. You see, you have encoder here, you have encoder here, here, multiple encoders of this. This is dot, which shows that you have multiple encoders, okay. Similarly, decoder maybe, decoder end maybe you will have multiple decoders, and you can see you are providing input here, right? We are providing input here and we are getting output here. The example which they are showing is that of language translation. तो ये कोई एक particular language है which they are using, which says com bitte her, something like that, okay. This is a particular language and the translation is please come here. So let's say German से English translation हो रहा है, ऐसा कुछ हो रहा है. You can example के तौर पे you can understand. So this is German language, okay, and this is English language, we all know. An example of language translation which they have taken, but वो हम लोग के लिए उतना important नहीं है. The important part is that if we consider the architecture, on the left side we are having encoder, but encoder ऐसा नहीं है कि multiple encoders, sorry, ऐसा नहीं है कि simply one encoder होगा. You can have multiple encoders here, okay. Similarly, decoder end में भी ये जरूरी नहीं है कि you will have only one decoder. You can have multiple decoders. This is the, I would say, most important part of your, I can say, entire transformer, जिसके चलते कि ये पूरा का पूरा change देखने को मिला था हम लोगों को, ठीक है. So this is the first point that you can note, that in case of transformers, this is the idea, okay. अच्छा, one more thing, the encoders and decoders that you can see, they are all identical in number. कहने का मतलब है कि अगर यहाँ पे 4 encoder है तो यहाँ पे 4 decoder ही रहेगा. This was again something which we did not consider in case of conventional encoders and decoders. I told you multiple times that you can have multiple, this is what, this is the architecture of many to many, है ना. Many to many architecture है ये, and in many to many I have told you previously that you can have many inputs and you can have many output, लेकिन जरूरी नहीं है कि जितना number of input हो उतना ही number of output हो, है ना. This is what I told you when we were discussing about these things. I had drawn a picture like this, ठीक है, मान लो इस तरह से आपका पिक्चर है। ओके, so this is what, this is the encoder section, right? This is the encoder section and this is the decoder section, right? And यहाँ पर क्या हो रहा है, you are giving the input, right? यहाँ पे context vector निकल के आएगा, this vector will be passed here as input, okay? You will be getting output here, then यहाँ पे output मिलेगा and then यहाँ पे output मिलेगा, okay? This is how things used to work, but यहाँ पर क्या है कि the number of input and output are not same, or you can say the number of encoder cells and the number of decoder cells are not same. Same हो भी सकता है, नहीं भी हो सकता है, okay? But when you are talking about transformers, okay, when you are talking about transformers, things will be almost same. बस एक change यहाँ पे देखने को मिलेगा कि you will have the same numbers of encoders and decoder. तो अगर यहाँ पर 4 इनपुट है तो 4 आउटपुट निकलेगा ही, okay? Something like this. Fine. Otherwise things are same only. Fine. लेफ्ट साइड में इनकोडर, राइट साइड में डिकोडर. इनकोडर एंड डिकोडर का जो साइज होगा या यू कैन से लेंथ होगा वो बराबर होगा, ओके? दिस इज व्हाट यू नीड टू रिमेंबर इन केस ऑफ ट्रांसफॉर्मर्स, ओके? नाउ अगेन द इनकोडर स्टैक, दिस इज द इनकोडर स्टैक यू कैन से, ओके? हाँ, अच्छा ये तो हम बोल दिए आपको कि इनकोडर एंड डिकोडर्स आर इन सेम नंबर, हाँ ठीक. So 2 things are supposed to be remembered. Apart from that, things are almost same. Okay. This is the entire idea of transformers. Now, why did we choose transformers? Transformers तो समझ में तो आ गया, but if we move one step ahead, okay. सबसे पहले फिगर कैसा बनाया था? सबसे पहले बनाया था, okay. So this is, you can say, figure 1, okay. So first of all, you have to refer this figure. You have to understand that on the left side you have encoder, on the right side you have decoder, right? Then we move to this particular figure, okay? You can consider any of these 2 figures, either ये जो हम बनाए हैं वो या फिर ये white वाला, okay? So this is figure 2. Even this is your figure 2, ठीक है? So figure 2 दोनों जगह है हम लोगों का, okay? Now what happens is we will move one step ahead and we will talk about the figure 3 here, okay? So this is the figure that I am going to talk about now. अब यहाँ पे देखो क्या हो रहा है, we are moving even in further depth. So this is your figure number 3. अब देखो यहाँ पर क्या हो रहा है, पहले तो superficially देख लो. This entire thing is what? Encoder है, you can see encoder 2, encoder 1, तो मतलब encoder है ये, है ना? Left side and right side में क्या है? Decoder है, right? Right side में decoder है. So idea था लेफ्ट साइड में encoder, राइट साइड में decoder, वो अभी भी है. 2 encoder है तो 2 decoder भी है, that is also fine. But now what we are doing is we are moving inside these encoders कि encoder के अंदर क्या हो रहा है. So the most important thing that you need to understand is that inside encoder you have self-attention, or you can simply understand that inside encoders or inside decoders also you have attention models, ठीक है? Attention model कहाँ पे लग रहा है? Encoders and decoders के अंदर, okay? So if you can recall attention model के बारे में क्या बताया था कल? If you can recall, can you tell me something? Encoders, decoder के बारे में क्या, sorry, attention model के बारे में क्या बात की थी? Simply consider the figure, let's say. Simply figure देखो, ठीक है? So this is the figure of your, let's say, I'll just mention it. This is your.
Yes, sorry, we have multiple inputs, and then we have one y cap.
Right, ठीक है. So you have multiple input and then you get one y cap, ठीक है? So यहाँ पर क्या होगा? We will try to merge it in a way which will give you a figure like this. अब आपको पता है कि यहाँ पर क्या है? Encoders है, okay? यहाँ पे क्या है, डिकोडर है. ओके, इनकोडर के अंदर, ओके ट्राई टू अंडरस्टैंड दिस, इनकोडर के अंदर अटेंशन मॉडल है. मतलब if this is your encoder, okay, and this is your decoder, okay, क्या इनकोडर के अंदर अटेंशन मॉडल है. मतलब इनकोडर के अंदर एक इनकोडर है ना. As you were saying, we will give multiple inputs. There will be an addition gate. Output will come from here, and you will have a decoder. ठीक है. यहां से क्या निकलेगा, यहां से निकलेगा y hat. ओके, एंड इनकोडर को इनपुट कौन दिया, x. ओके, फाइन. This is what you have. Similarly, decoder में क्या बोल रहे हैं, decoder में भी attention model है. मतलब वहां पे भी encoder होगा, multiple inputs passed to the addition gate. This will be passed to the decoder. Okay, decoder से निकलेगा क्या, decoder से निकलेगा y hat. इसको y मान लो क्योंकि it is intermediate in nature. ठीक है, so ये चीज है, and this is final yf, or you can say final output. Okay, now this yi will also act as context vector. Okay, and we will try to pass this here as input to the encoder. Okay, so encoder, decoder वाला जो encoder है, try to understand in this way, decoder वाला जो encoder है उसके अंदर input क्या जा रहा है, this, and you get y hat f as the final output. ठीक है, this is the architecture of your attention model, sorry, transformers. encoder decoder होगा. अब देखो this figure में, I'm just trying to simplify this particular figure for you, this one. ठीक है, यहाँ से दो encoder decoder है, तो ये तो एक बना ली. ठीक है, let us say you have one more. Okay, क्या करेंगे, again very simple, एक बॉक्स बना लो. Let us make it very simple. Okay, this is the encoder section, this is the decoder section, right? encoder के अंदर encoder होगा, input दिया जाएगा, addition gate होगा, decoder को दिया जाएगा, and decoder से क्या निकलेगा, सिमिलरली यहाँ पे भी डिकोडर के अंदर इनकोडर होगा. ठीक है, this is how you are going to stack different attention models to form your transformer. Again you can name them. मान लो ये encoder 1 है, ये decoder 1 है, ये encoder 2 है, ये decoder 2 है, something like that, and this is how things will proceed. So always remember that in case of transformers there are three things which are happening and they are important for us. First of all, on the left side you will have encoders, on the right side you will have decoders. Second thing to remember is the number of encoders and the number of decoders are going to be same. कुछ भी हो जाए, the number of units are going to be same. तीसरा thing that you should remember is that when we say that on the left side we have encoders and on the right side we have decoders, we also mean that inside encoders or decoders, for that matter of fact, you will have attention models or self-attention models inside it. मतलब इनकोडर के अंदर इनकोडर डिकोडर दोनों होगा, डिकोडर के अंदर भी इनकोडर डिकोडर दोनों होगा. किस फॉर्मेट में? अटेंशन मॉडल वाले फॉर्मेट में. तो अटेंशन मॉडल वाला फॉर्मेट क्या होता है? लेफ्ट एंड राइट नहीं, अप एंड डाउन. ओके, सो अटेंशन मॉडल में अप एंड डाउन होता है, मतलब अप में डिकोडर, डाउन में इनकोडर. उस तरह का आर्किटेक्चर होगा. कहाँ? इनकोडर एंड डिकोडर दोनों के अंदर when we are talking about transformers. ठीक है? So this is the final architecture that you are going to have. So you can name this figure as final figure or figure 3. ये final figure 3 है. Okay, just have a look. Tell me if it is clear. This is the entire intuition of your transformers. एक बार देख लो.
Yes, I think it's fine, sir. So basically, we are trying to say that like decoder of encoder one is actually the encoder of decoder this thing, no?
I could not hear you. Once again, please repeat.
So basically, what we're trying to say is that the decoder of the encoder one, so it becomes the input for the decoder of
Decoder
one,
one.
right?
Right, right.
Okay.
Or you can simply say that the output of decoder of encoder one. Okay, because output transfer hota hai na. So output of decoder of encoder one acts as input of encoder of decoder one.
Okay. Yeah. Okay. Yeah.
Same way here also, in this figure also. The output of decoder of encoder 2 becomes the input of encoder of decoder 2. ठीक है? Just try to draw this figure when you get time after the class. एक बार इस figure को खुद से बना के देखना, you will be able to understand. ठीक है? We are just combining all these things together. Attention model and transformer दोनों को mix कर दे रहे हैं.
Yeah.
Right. So this is your transformer, and we have these figures for you to see. Okay, you see self-attention is here, self-attention is here. All of them are here, working in the same fashion. Fine. So this was your transformer. Now coming to the second important part of our discussion for the day, which is known as BERT. And I guess BERT is the last topic for your syllabus also. So बात करते हैं BERT के बारे में. Again, I could have shown you the picture of BERT taken from the internet, but वो बहुत ज़्यादा complex है. वो देख करके कुछ समझ में नहीं आएगा, बेमतलब इंसान confuse हो जाता है. So it is better that I draw the picture by myself so that you are able to understand. ठीक है? So बात करते हैं about the latest thing which is there in the market according to your syllabus, which is bidirectional encoder representation from transformers, which is also known as BERT. Okay, so what is BERT? It is bidirectional encoder representation from transformers. Now the name itself suggests that you will have bidirectional elements into picture, you will have encoders and decoders in picture, and you will have transformers in picture. ये बहुत सारा चीज को एक साथ mix करने वाला है. Okay, so we will have to have some patience here, and we will try to understand that how things are going to work here. Okay, अगेन फिगर समझ में आ जाएगा तो सब कुछ समझ में आ जाएगा। ओके, सबसे पहले लेट अस गो फ्रॉम बैकवर्ड, सो वी विल गो फ्रॉम बैक टुवर्ड्स फ्रंट। मतलब पहले बात करेंगे ट्रांसफॉर्मर्स के बारे में, देन वी विल टॉक अबाउट एनकोडर्स, एंड देन फ्रॉम हियर वी विल टॉक अबाउट बाई डायरेक्शनल आरएनएन। बस आपको याद होना चाहिए कि कॉन्सेप्ट क्या था बाई डायरेक्शनल आरएनएन का, कॉन्सेप्ट क्या था एनकोडर का, एंड कॉन्सेप्ट क्या था ट्रांसफार्मर का, ये चीज बस याद होना चाहिए। ओके, so let us go step by step. Let us talk about transformers first. So I will just number them for you to understand. You need not number them in your notes. ठीक है, तो सबसे पहले बात करेंगे ट्रांसफार्मर का। सुपरफिशियली अगर बात किया जाए तो ट्रांसफार्मर क्या है? ट्रांसफार्मर इज encoder and decoder in this way. Okay, so you have encoder and you have decoder, right? Fine. Now because it is a transformer, it will have attention mechanism inside it. कहने का मतलब है कि encoder होगा यहाँ पे, decoder होगा यहाँ पे, right? बीच में एक addition होता रहेगा, right? Simple. Same way here also, encoder is here, decoder is here, बीच में एक addition हो रहा है, right? Simple as that. This is what we have just seen. तो ट्रांसफॉर्मर वाला पार्ट हो गया, encoder decoder वाला पार्ट हो गया. Now comes the important part, which is bidirectional. Okay, so when we say bidirectional, इसका मतलब क्या होगा? देखो, अगर I say एक superficial diagram बनाने के लिए of BERT, so this is it. This is what you have to do. Okay, BERT का superficial diagram यही होगा, or you can just try to make it a bit more beautiful by doing all these things. Okay, so you can simply say yi, you can transfer it here by I. Okay, all this labeling you can do by yourself. Okay, so this is what we have in case of but also. Okay, but एक छोटा सा change है यहाँ पे, छोटा सा नहीं, actually थोड़ा बड़ा change है, which is that we are going to use bidirectional RMNs here. मतलब both encoders and decoders that you have, they will not have conventional RMN cells. Okay, what they will have is bidirectional cells. Okay, or bidirectional RMN cells. अब इस चीज को थोड़ा सा समझो. If we talk about normal RNN cells, this is how they look, है ना? यहाँ से इनपुट दिए, यहाँ से आउटपुट आया, यहाँ से इनपुट आउटपुट इनपुट आउटपुट, ठीक है? मान लो x1 आया, y1 hat, x2 दिए, y2 hat, x3 दिए, y3 hat, right? This is your, just a second, this is your conventional RNN diagram. Now when I am saying that this is RNN, simple RNN architecture, okay, when I am saying bidirectional RNN, what do I mean? Bidirectional में क्या होगा? Again, we have discussed these things. I'm just recalling. ठीक है, इसमें क्या होगा? You will give x1 as input. You will get y1 hat as input. Sorry, as output. Then this will be passed as input. Okay, this will be passed as input x2 के साथ. Okay, x2 के साथ, and you will get y2 hat. So y2 hat is the output that you get when you are passing y1 hat as well as x2. ठीक है? Similarly, y2 को इधर ट्रांसफर किया जाएगा. Okay, y2 को इधर ट्रांसफर किया जाएगा, y2 hat, sorry, y2 hat को इधर ट्रांसफर किया जाएगा, and x3 तो जाना ही था ऐसे. So x3, and then the output you get is y3 hat. Okay, this is what we have. Again, these are connected. These are connected in the same way. Okay, So this is what? This is bidirectional arrow. ठीक है, कहने का मतलब है कि ये जो लूप बना है ना येलो कलर का, that is the game changer for us. Okay, and यहाँ पर when we are talking about your BERT, वहां पर encoders and decoders में we will not be using RNNs. Okay, हमेशा हम लोग RNN यूज करते हैं, यहाँ पर RNN का यूज नहीं होगा, यहाँ पर यूज होगा bidirectional RNN का. Okay, so यहाँ पर when we are saying encoder और decoder और यहाँ पे भी decoder encoder कुछ भी है, तो वहां पर RNN ना लगा करके क्या लगाएंगे? Bidirectional RNN लगाएंगे. ठीक है, that is the only difference. So if I have to draw the figure, I guess आपको समझ में आ गया होगा what I'm trying to say, but still let us draw the figure once. Okay. ठीक है, x1, x2, x3, and you get y as the output or y hat as the output, or according to our nomenclature y I hat. ठीक है, this is the entire encoder part. This is entire encoder part. So encoder part, यहाँ पर भी अगर ध्यान से देखा जाए, so this is encoder and this is the decoder, right? Yeah. अब यहाँ से जो output निकल के आया, okay, this will be the context vector and this will be passed, okay. ये जो W आया context vector, this will be passed, right? So this will be passed like this, and यहाँ पर again you will have the decoder section. So अरे just a second. Right. So this context vector, or you can say y hat, yi hat, will be passed here, and again same चीज होगा यहाँ पर भी. Have the encoder section. Okay, you will have the encoder section like this. You will have the adder. Output will come from here. It will be passed to this particular cell, and then YF final. Okay, this is what you are going to have. अच्छा, यहाँ पर, sorry, I made a mistake. You will not have 3 inputs. You will just have 1 input. Okay, क्योंकि एक ही input आ रहा है ना, input तो एक ही आ रहा है, which is nothing but your yi hat. ठीक है, so this is only going to be transferred like this, and finally you are going to get the output. Again, this entire thing is your decoder. This is your decoder part. Fine. And again, if you look closely, this is decoder in itself, and this is encoder in itself. Okay. So essentially, if I give you one more point here, what we are doing, we are providing input here and we are getting the final output from here. Okay, this is how things are going to work. This is your BERT. अब ऐसा समझाया हुआ कहीं पे भी आपको गूगल पे मिलेगा नहीं. I tried to figure out a picture so that मेरे को इतना मेहनत ना करना पड़ता, but अफसोस मेरे को मिला नहीं. ठीक है, तो कोई बात नहीं. Now you have the figure and I guess you are able to understand. So this is how things are working. Okay, and you can see all the properties of transformers are taken into consideration. मतलब यहाँ पर भी the number of encoders and decoders will be same. यहाँ पे भी encoder will be on the left side, decoder will be on the right side, and the only difference that you will have is that in case of transformers, encoders and decoders that we were having, they used to have conventional RNN cells. ये वाला होता था उसमें, ठीक है. ट्रांसफार्मर में ये वाला यूज होता है, लेफ्ट साइड वाला. But in case of BERT, you use bidirectional RNN. So I will just mention this point also. This is used in case of transformer. Okay, bidirectional RNN जो है ये यूज होता है BERT के केस में. Okay, just have a look. This is what we have for BERT. कोई question है कहीं तो you can ask me. In fact, you can just have a look into this picture also. मतलब अपना encoder decoder वाला ये वाला figure भी you can see. कहीं कोई doubt है आज की क्लास में तो you can ask me. This is what we have. Just see.
Sir, in the BERT, yeah. So the W vectorizer. So is it not near that, as in the attention models, the plus symbol. So where we are converting the thing to the numerical format.
So W is nothing but the numerical format only.
Yeah,
But
yeah.
यहाँ पर because yi will also be numerical in nature only, because everything is numerical here. This is numerical, this is numerical, this is numerical. So obviously this will also be numerical only. So you can either say yi is being transferred as input to decoder section, or you can say W vector. क्योंकि हम लोग encoder decoder में पढ़े हैं कि W vector को transfer किया जाता है. तो W vector क्या है? Numerical format ही है. तो वो चीज यहाँ पे भी. So either you can say this or you can say this. Does not matter.
Yeah. So we can put near the plus symbol also one W arrow, and then here also one W arrow if we want to.
Yeah, this can also be done, right? That can also be done. क्योंकि यहाँ पर even that will be better for you. So मान लो ये इस तरह से आया. Okay, you can consider it in that way. यहाँ पर W you can write. यहाँ पर W you can write. कोई दिक्कत नहीं. Okay.
Yeah, we can also write as you have written, because that is also acting as an.
That is also true. That is also true.
Yeah.
क्योंकि W है क्या? We first of all need to understand that what is W. So W is the vectorial representation. The same thing is being represented with respect to yi also. Same thing. कोई दिक्कत नहीं.
Yeah. Okay, sir. That's it. Yeah.
Fine. So this is like एक छोटा सा figure है, but इस figure के अंदर बहुत सारा चीज है that we need to understand and that we need to like keep in our mind. ठीक है. So this is the figure of your BERT. Okay. Most important thing is this particular cheese, bidirectional RNN का use. Okay. Again, while discussing about bidirectional RNN, I told you that there are few drawbacks of bidirectional RNN. जैसे कि this is slow, है ना? ये slower काम करता है as compared to RNN, है ना? RNN they are fast, LSTM they are fast, GRU they are fast, but bidirectional RNN are slower in nature. क्यों? क्योंकि ये loop वाला system आ गया ना यहाँ पे. ये पीला वाला जो line I have drawn, this actually leads to you can say speed जो होता है processing का, which is known as computational efficiency, that becomes a bit slower in case of bidirectional RNN. And because we are using bidirectional RNN in case of BERT, you will find कि BERT भी थोड़ा slow काम करेगा. Okay, so you will ask me कि सर अगर BERT slow काम कर रहा है and BERT has been developed after transformer, तो ऐसा चीज क्यों किया गया? Like why people are still using BERT even if it is slow and all? तो देखो slow है कोई बात नहीं, but efficiency ज्यादा आता है उसका, मतलब output जो देगा वो ज्यादा अच्छा देता है. Because you will notice that bidirectional RNN will take care of long-term dependency, which was a problem with conventional RNN. तो ट्रांसफॉर्मर क्योंकि RNN यूज करता है, यहाँ पे क्या होगा? लॉन्ग टर्म डिपेंडेंसी आएगा. ठीक है, लॉन्ग टर्म डिपेंडेंसी वाला प्रॉब्लम आएगा. ठीक है, बट because it is using bidirectional RNN, long term dependency will not be there. ठीक है, ये चीज नहीं होगा, ये चीज यहाँ पे होगा. So whenever you are studying, try to correlate it in this way so that you are able to revise also the previous topics as well as you are able to understand कि ऐसा नहीं है कि जो भी हम BERT के बारे में आज बता दिए उतना ही काफी है. If you try to connect the dots, you will find कि अब देखो I have already talked about bidirectional RNN, so I will not again talk about the same thing today and waste your time. But you can just refer to that particular lecture and you will notice कि I have talked about these things, that bidirectional RNN is slower. Okay, because of this looping mechanism, है ना? तो because bidirectional RNN is slower, this is also something that you will find in case of BERT, क्योंकि BERT bidirectional RNN use कर रहा है ना? So because bidirectional RNN is slower, BERT will also be slower. Because transformer uses RNN and RNN is comparatively faster as compared to bidirectional RNN, that means transformer speedily काम करेगा as compared to BERT, है ना? इस तरह से you will have to compare the things so that you are able to revise also and you are able to keep these things in mind. तो comparative study जब करते हैं तो चीज थोड़ा ज्यादा दिन तक दिमाग में टिकता है. Okay, so this is what we have.